Hi, guys. Today we're starting a new chapter. So, not just a new unit, but a whole new chapter. Today we are starting chapter 3, which is all about inequalities. Now, in chapter 2, we were learning about equations. So, an equation is something with an equal sign, and we can solve for x and get something like x equals 5 or x equals 23,000. In this chapter, we're going to replace that equal sign with an inequality, and we'll still be solving for x, but there's going to be a couple little tweaks to what we're doing in the problem. So let's go ahead and get started by learning what an inequality is. So, an inequality is a mathematical sentence that compares the values of two expressions. Now, they're not going to be equal to each other, so don't be thinking like, oh, it's going to be like x equals 5, and then it's just the number 5. Instead, an inequality could be a less than symbol or a less than or equal to symbol. And so here are two examples of inequalities. Notice that even though I called it a less than symbol, the phrase that we use to go with the less than symbol is less than. And that teeny tiny little word is going to be super important when we are translating sentences into math problems. So we have is less than or equal to, and then, the opposite of that, which would be is greater than, and is greater than or equal to. Okay, so those are our four inequalities, and that's what we're going to be using this chapter. So essentially the same thing that we were doing in the first chapter, but instead of an equal sign, I'll put one of these four symbols. We're going to start today with translating some sentences into a math problem. And we're not going to be solving math problems today. We're just going to focus on, can I get it from words into a math problem? So this one says that x is less than or equal to -7. And so we're pretty much just going to take it as it is. The x was written first. It's going to be written first in my math problem. -7 was written last. It'll be written last. And then I just need to figure out which symbol to use. If you're having trouble remembering which symbol is less than and which symbol is greater than, a less than can kind of be drawn almost like a letter L. It's almost like you're drawing an L, but then you're squashing it. Okay? So pretend like you're drawing a letter L and then squish it down a little bit, and that's the less than symbol. Let's try another one. In this problem, it says 6 less than a number k is greater than 13. 6 less than a number k is greater than 13. Now, this one's a little bit confusing because it actually has two phrases that seem like they should be inequalities. But we don't want to write two inequalities. We only want to have one inequality. So we got to figure out which phrase is the inequality and which phrase means something else. So the phrases that I see are less than and greater than. One of them is the inequality, and we can tell which one is the inequality by that little teeny tiny word is. Since greater than has the word is in front of it, that's the one that we're going to use for our symbol. So I will be using a greater than symbol. That means that the phrase less than is actually talking about a subtraction problem. Now, less than is a pretty tricky phrase. We're actually not going to do 6 minus k. When you see the word than or from in a subtraction phrase, you're going to flip-flop the order. And so instead of doing 6 minus k, I'm going to do k minus 6. So what I usually do is I'll write down the number 6 because I saw it first. Then when I see a less than, I'll write the minus sign in front of the 6 instead of after the 6, because less than tells me to switch the order, which means the 6 comes after the minus sign. And then continuing to switch the order, I'll write the k in front. So again, 6 less than a number k means k minus 6. Order does matter on a subtraction problem. If you write it in the wrong order, it will be considered wrong. Then I can put my is greater than symbol and then finish up with the number 13. So here are two examples of translating from a sentence to math. On your homework tonight, it is just translating from a sentence to math. There's no solving, okay? So just Write it out exactly how it's said, and then stop and move on to the next problem. Let's move on to the next problem. I have one more example to show you before the end of today's video. Continuing with this whole translation concept, we're going to translate this sign, this concept, this real life example into an inequality, okay? So this is kind of like a word problem, but with a picture instead of a paragraph. Just like on our word problems, we're going to be defining a variable. It even tells us to do that in the directions. And then we'll be writing an inequality to represent what this problem is talking about. In this problem, it says that trail rides start at a price of $19.99. And so what we want to do is we want to write a math problem that shows how much a trail ride could potentially cost. And so since we're showing how much a trail ride could cost, that's what our variable will be. So I chose to use the letter C. You can use whatever letter you want. I chose C for cost of a trail ride. According to the sign, a trail ride could cost $19.99, but that's the starting price. That means it also could cost more than $19.99. So if I want a trail ride to equal $19.99 and also be more than $19.99, I'm going to say that the trail rides are greater than or equal to $19.99. Okay, so for this problem, I would write down two answers. I would write down my variable that I chose and what it represents, and then I would write down the inequality that tells me about this picture or a word problem for your homework. That's it for today.